Okay, we're coming to the conclusion of this first chapter, section 1-1 on functions. And in this chapter section, we've described subsets of real numbers. We've talked about using set builder notation and interval notation. We also talked about how to identify functions. And our key thing there is that for every value of x, or the independent variable, that for any value of x, it can equal only one y value, and the y value being the dependent variable, for a relation to be a function. Now, we can have relations that are not functions, but if it is a function, for any value of x, there is only one y value. So if x equals more than one y value, we know that it is not a function. And along with that, you can visually see that on a graph by applying the vertical line test. If a vertical line were to cross the graph more than one time, it is not a function. Now, we also went into function notation, f of x, and we used that to find function values. And we also talked about implied domain meaning that the domain is assumed to be, initially at least, all real numbers, but there can be some restrictions to that. And the two major things that impose a restriction to the domain of all real numbers is you can't divide by 0, and you can't take the square root of a negative number. Square root of a negative, or an even root of a negative number, I should say, really. You can take an odd root of a negative number, but you cannot take the even root of a negative number. That would be an imaginary number, and an imaginary number is not a real number. And then lastly, we come to this little piece about evaluating piecewise defined functions. And so a piecewise defined function is a function that is defined using two or more equations for different intervals of the domain. That is a piecewise defined function. And so this corresponds here to example 6 in your textbook on page 8. And so we're given this scenario. The speed v of a vehicle in miles per hour can be represented by the following piecewise function. When t is the time in second, find the speed at each indicated time. So if we're viewing this, let's say, on a graph, well, the y-axis would be our measure of speed, and the x-axis is our measure of time in seconds. So we're given these three piecewise functions. What is the speed at given intervals of time, t, when the time elapsed is when time is greater than or equal to 0, but less than 15? Well, we can determine that time in this scenario by 4 times the number of seconds. That will give us the speed. And if the time in seconds is greater than 15 seconds, but less than 240 seconds, or 2 minutes, then we're going at our speed is 60 miles an hour within that time interval. And if the time elapsed is greater than or equal to 240 seconds, or 2 minutes, but less than or equal to 250, we're given this equation: negative 6t, negative 6 times the number of seconds, plus 1500. And then we're just simply asked to find the values of our speed in v given 3 different measurements of time. And so in this first one, what is the speed when the time elapsed is 5 seconds? And so we're looking here at our 3 equations to determine where this would fall. And this would fall here in this first inequality statement, where time is between 5 is between 0 and 15 seconds, and that's just the measure of that is simply 4 times the number of seconds. In this case, that is 5, and so 4 times 5 is 20 miles per hour. All right, our second scenario. What about after 15 seconds? What is our speed? Well, it would actually fit back into this first inequality statement, because we see in this second one here, the time would have to be greater than 15 seconds, but this is exactly 15 seconds, so it falls in this less than or equal to, and that's 4 times 15. Well, 4 times 15 is 60 miles per hour. And if it was 16 seconds, it would also be 60, because that would be greater than 15 but less than 240. And then lastly, after 245 seconds, what is our speed? Well, that's going to fall into this last inequality statement, which says that it is negative 6t plus 1500, and I'm probably going to need my calculator for this one. So negative 6 times 245, well, that equals negative 1470. And I got to add to that 1500. And so my final answer then is 30 miles per hour. And if we were to look at this graph, it would probably look something like we see an acceleration and then we see it tail off, and it looks something like that, I would suppose. Or actually, I guess it would level. Because we'd see an area of acceleration, then it would level off, and then it would drop. So, speed of this vehicle is accelerating over the first 15 seconds. Between 15 seconds and 2 minutes, it kind of levels to 60 miles an hour. It wasn't a very good straight line right here. That should be straighter. And then it decelerates after 2 minutes. Okay, there we go. We've evaluated a piecewise function. We'll see piecewise functions crop up every now and then. Not all that often.